Welcome back, dear students. So we have learned about the hydraulic circuits, the symbols for different circuits, different components of the hydraulic system. So now we will study in detail those systems, starting with hydraulic pumps. So what do you mean by a pump? Pumping means what? Pump. You have heard about pumping the blood inside our body, right? Heart is pumping the blood to the different parts of the body. So heart can be considered as a pump, isn't it? That is what the heart is doing. It is pumping means what? It is pressurizing the fluid. It is pressurizing the fluid. Fluid is nothing other than blood. Okay, the blood will be pressurized so that it will be reached all parts of the body. So similarly, the pump will be pressurizing the fluid, incompressible fluid, in the lines to reach the destination. So this session or the upcoming 3-4 sessions will be discussing about various types of pumps and understand how the working of the pumps is. Okay. So what is the basic difference between a pump and a turbine? So pump is a device to pressurize the fluid, or pump will be adding energy to a fluid. So pump will be adding energy. A pump is usually run by an electric motor. Electric motor will be converting electrical energy to mechanical energy, and pump will be converting mechanical energy to hydraulic energy. So mechanical energy will be given to the pump, and that will be added to the fluid so that mechanical energy is converted to hydraulic energy. So the end result in a pump is an increase in pressure from inlet to outlet. On the other hand, in a turbine, which converts hydraulic energy to mechanical energy, you can see the shape difference. This is the area from the inlet to outlet is decreasing or converging. In the case of a turbine, the area is increasing. If you have seen my previous video on Rankine cycle, there I have explained the turbine. The expansion is taking place, whether it is steam turbine or a hydraulic turbine or an air turbine, whichever the case is, in a turbine, expansion will be taking place. That means pressure will be reduced. At the expense of pressure energy, something else will be increased. So, turbine extracts energy from the fluid, that is hydraulic energy. The energy contained in the fluid is hydraulic energy, resulting in a decrease in pressure. Resulting in a decrease in pressure across the turbine. So this is the difference. We are getting work output from the turbine. We are giving in work to the fluid via the pump. Now both are hydraulic devices. Pump is a device which converts mechanical energy to hydraulic energy, but turbine is a device which converts hydraulic energy to mechanical energy. Pump add energy to the fluid. Turbine extract energy from the fluid. So you may note down all these important but fundamental simple terms. If somebody is asking you to differentiate between pump and turbine during an interview, it will be very useful. So you should know the fundamental difference and how to represent a pump and a turbine through schematic diagrams. That is also very important. So pump is driven by an electric motor, but a turbine will drive an electric generator because it is generating some mechanical power. So in the case of pumps for gases, compressible fluids, the pumps are known as in three names: fans, blower, or compressor. Are you wondering? Fan is a kind of a pump for gas, compressible liquid. Blower is also the same category. Compressor is at a higher level, which can deliver highly pressurized gas compared to blower and fan. So all these three, fan, blower and compressor, can pressurize a compressible fluid. But the range of compression only is the difference among these three. Now coming to the classification of pump or turbine, there are two major classifications: positive displacement machines and dynamic machines. In the case of positive displacement machines, there is a closed volume. A certain volume of the fluid will be displaced from one place to another. The common day-to-day life example for a pump is a human heart. For turbine, the home water meter. Some of you will be having the corporation water coming into your home, right? So there on the line, they install a meter to measure how much quantity of water is consumed. So that home water meter is an example for turbine, because they convert hydraulic energy to mechanical energy, and mechanical energy will displace the needle. Dynamic machines, on the other hand, having no closed volume. Instead, rotating blades supply or extract energy. So there is no fixed volume to be displaced from one place to another. It is open. Rotating blades will be there. It will supply or extract energy. Then there are other categories under dynamic machines: enclosed or ducted pumps, open pumps, enclosed turbines, and open turbines. All these are coming under dynamic machines. Even wind turbine is a kind of open turbine. Now coming to the classification of pump alone, under positive displacement we have reciprocating pump and rotary pump. Reciprocating pump and rotary pump come under the category of positive displacement pump. Under rotodynamic pump we have rotary pump, and in that centrifugal pump is the major one, which we will discuss in detail. Then there are special designs like jet pump, electromagnetic pump, or hydraulic ram. All these are category of rotodynamic pumps. Now, you have heard about pumping, right? Pumping the blood by the heart. So the word pumping refers to a hydraulic system commonly implies to convey liquid from a low to a high reservoir. That means from a lower pressure to higher pressure. So here we know that pressure will be energy will be added to the fluid by a pump, right? So obviously pressure will be increased. So from a low reservoir to a high reservoir, when the fluid is lifted, that is commonly known as pumping, because the opposite will happen automatically under the effect of gravity. From a higher level to lower level, we do not need to employ a pump. We don't need to consume energy for that. By default, the fluid will flow under the effect of gravity. The total head at any point comprises pressure head, velocity head, and elevation head. These three are the important heads at any point in a pumping system. Now coming to the pump head, as I mentioned, the velocity head, pressure head, and elevation head. So you can see here there are two lines: energy gradient line at the outlet and energy gradient line at the inlet. So V stands for velocity, P stands for pressure, and Z stands for elevation. So velocity head, pressure head, and elevation head. So there is a reference plane, datum plane, where Z is equal to 0. So the inlet is situated at this much distance, and the fluid is entering to the pump at a certain velocity and at a certain pressure. Fine. So up to here, that will be retaining. So total energy gradient line is up to this level at the inlet, and then you have at the outlet similarly it will be leaving at a velocity and a pressure, and the elevation at the outlet will be different. The net head is the difference between the energy gradient line at the outlet minus energy gradient line at the inlet. Is it clear? So energy gradient line means the sum of pressure, velocity and elevation. Now the water horsepower. Water horsepower, that is mechanical energy, will be converted to hydraulic energy, right? So the output of the pump is rho g QH or rho g V dot H. V dot is the volume flow rate, and H is the head. You can see the head. H is the difference between EGL out and EGL in. Fine. M dot is the mass flow rate. So mass flow rate is rewritten like this, rho into V dot. Now the brake horsepower, that is the shaft power, this is the shaft. Okay, the mechanical energy, that is given by omega into T of the shaft. Omega is the angular velocity, T is the torque of the shaft. The pump efficiency is the ratio of output and input. This is output, water horsepower, and this is the input which should be given to the pump shaft via a motor, electric motor. Clear? Yes. Now, as we have mentioned, there are two categories of pump: positive displacement pump and uh, rotodynamic pump. Now, positive displacement pump, as we have mentioned, will squeeze out a certain quantity of fluid from one place to another. Ideation of piston cylinder arrangement, or some gear kind of arrangement, or vane kind of arrangement. All these could displace a certain quantity of fluid from one place to another. So positive displacement pumps, or PDPs, force the fluid along the volume changes. Force the fluid. So a certain quantity of fluid will be trapped as a pocket of fluid will be displaced. A cavity opens and the fluid is admitted through it. So we will see in detail the working of the positive displacement pumps, such as reciprocating gear, vane, or lobe pumps in the coming sessions. Okay. So at that time it will be more clear to you. So liquid is sucked and then pushed due to the thrust exerted on it by a moving member. So that is what happening here. Okay. So by a moving member, the liquid will be set and pushed due to the thrust exerted on it. So mechanical power will be given to the fluid by the rotation of shaft, or um, the movement of a piston, like that. Examples. The most common and beautiful example is the human heart. Blood is pumped by expansion and contraction of the heart chambers called ventricles. Then common water meter in your house. That is a positive displacement turbine. Applications of positive displacement pumps. So they are ideal for high pressure applications. When you require very high pressures, like pumping viscous fluids or thick slurries, especially in wastewater management system and all, we can use this positive displacement pumps. Then for applications where precise amounts of liquid are to be dispensed or metered, precise amounts, especially in medical applications, we can use positive displacement pump. Now coming to the second category, that is rotodynamic pump. They are simply add momentum to the fluid as a result of some rotation of the shaft. So it will be having some blade kind of arrangements, and momentum, that change of momentum will be transferred to the pressure energy. So velocity energy will be converted to pressure energy here. So by fast moving blades or vanes. So there is no closed volume as in the case of positive displacement pump. So as the liquid passes through the rotating member called impeller, the rotating member in a rotodynamic pump or dynamic pump is called an impeller. Okay. The counterpart of impeller in a turbine is a rotor. Its angular momentum changes, which results in increase in pressure. So as I mentioned, the kinetic energy, the rotation of the impeller will be imparting a momentum to the fluid, incoming fluid, and it will get pressurized. So these are the differences. To summarize, positive displacement pumps provide lower flow rates but very high pressure rises. The flow rates will be The volume flow rate will be less, but pressure rise will be high. But on the same time, rotodynamic pump provide higher flow rates. For example, centrifugal pump. If you need to lift water from a sump or your well in your home to our head tank, we use a centrifugal pump instead of a positive displacement pump because we need higher flow rate, right? Within a short period of time, we need to fill the tank. So we are using rotodynamic pump there. Then positive displacement pump is not having continuous discharge. Discharge means volume flow rate delivery. Okay. So for that, if you want a steadier discharge, you have to use a rotodynamic pump. High viscosity fluids can be handled by positive displacement pump, but rotodynamic pumps are not effective in handling this high viscosity liquids. So positive displacement pumps are self-primed. No need to prime it separately. We will see what priming is. Some of you might have already knowing that rotodynamic pump need priming. So having said that, we have summarized the difference between positive displacement and rotodynamic, and we have seen the classification of pump. We have studied what is the difference between pump and turbine. We'll stop for today's session. We'll continue the next session with reciprocating pumps, the working, some fundamental equations, and the different parts. Okay. So thank you for watching. Please subscribe to the channel and get notified on the upcoming videos. We can go to the playlist. There are different topics are listed there, such as renewable energy, internal combustion engines, and thermodynamics. Whichever subject suitable to you, you can watch or you can comment in the chat box below for new videos. If you have some special request for any subjects under thermal engineering stream, you can always have a request on the comment box. So please be informed. Thank you for watching. Have a good day.